All right, my secondary math 1 kids, we are going to be starting a new unit today. That unit is square roots and radicals. Okay, so hopefully you've at least heard of the term square roots. Radicals might be new, but we're going to talk about these today. Okay, so let's look at number 1. So for number 1, it asks us to list the first 11 perfect squares. Okay, so what I want us to do is right in this spot right here, I want us to make a list from 0 to 10. Okay, counting 0, that'll give us 11 perfect squares. Okay, so let's start at 0, 0, and then let's go to 10. 1, 2, 3, 4, 5. Okay, we'll go over here. 6, 7, 8, 9, and 10. Okay, so those are our first 11 perfect squares. Well, we need to do something before we get to their perfect squares. So making a square means that we are multiplying something by itself. Okay, so what we're going to do is we're going to take 0 in every number and we're just going to multiply it by itself. So 0 times 0, 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, and 10 times 10. Okay, so we're not quite to its perfect square yet because now we need to decide what are these actual numbers when we multiply them by itself. Okay, so now let's write, what is 0 times 0? It's just going to give us 0. What's 1 times 1? 1. 2 times 2? 4. 3 times 3 is 9. 4 times 4? 16. 5 times 5? 25. 6 times 6? 36. 7 times 7? 49. 8 times 8 is 64. 9 times 9, 81. And 10 times 10, 100. Okay, you could keep going on with all the other numbers. We're just going to go up to 10 for now, okay? So these guys, what the answers that we got, these are our perfect square numbers, okay? It's when you multiply a number times itself and it gives you that number, okay? So 6 times 6, we know that 0, 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100, and more numbers. If we were to go past 10, these would be perfect square numbers, okay? So let's look at number 2. Why are they called perfect squares? Okay, well, let's just take 3 times 3, for example. Okay, so we're going to take 3 times 3, and we're just going to draw a square. Okay, so if we take 3 times 3, 3 times 3. Okay, so that means I'm going to split this box into 3 squares right here. Okay, and then I'm going to do the same thing on this side. Okay, because we have 1, 2, 3 times 1, 2, 3. Okay, now what does this make? It makes a perfect square. Okay, we could do that for all of them, but I don't really want to draw out 100 boxes, okay? But this is why they're called perfect squares, because if you add 3 on this side, 3 on that side, it creates a perfect square. Okay, if you wanted to add 1 more to make it 4 times 4, that would also create a perfect square, meaning you have the same amount of boxes on each side. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, remember a square has the same measurement of all its sides. Okay, so that's why we call it a perfect square. Okay, so let's look down at 3 through 10, you guys. Okay, looking at 3 through 10, you can't see 10 up here on the video, but look at 3 through 10 and identify, are there any perfect squares numbers? Okay, Are there any numbers inside these radicals? Okay, in fact, let's define that right here. So this little sign right there, that's called a radical sign. Okay, so all these numbers are inside these radicals. Okay, but can you see any numbers that are also on this list we made up here? Okay, 0, 1, 4, 9, 16, all these guys. Okay, do we see any? Okay, I see 64, right? That was a perfect square. That was 8 times 8. Okay, I also see 16. Okay, that was another perfect square. That's 4 times 4. Okay, and I see 36. That was another perfect square. That is 6 times 6. Okay, so for now, let's just put a star by those, knowing that these guys are perfect squares. Okay, and I'll show you why these guys are perfect squares. Okay, but for now, we're actually going to learn how to simplify these guys when the number inside is not a perfect square. Okay, 8, for example, is not a perfect square, right? We don't see 8 anywhere on this list, right? It goes from 4 to 9. So we know that 8 is not a perfect square. Okay, so how in the heck are we going to square root it? Because that's the other thing that this sign means. Okay, it's a radical, but it also means to square root it. Okay, and square root means, let me zoom this out, and I want you guys to write down this definition. What number multiplies by itself? Okay, what number multiplies by itself? Okay, well, let's look back at 8. Okay, pause that video, rewind if you need a little more time to write down that definition. Okay, 8. Is there any number that multiplies by itself to get 8? Nope. We know 2 times 2 gives us 4, and 3 times 3 gives us 9. 4 plus 4 would give us 8, but not multiplying. We're talking about multiplying, right? So let's look at 8. So here's how we want to think about these radicals. Okay, think about these radicals as a house, okay? Now, in order to leave the house, we'll say that a number needs to pair up with its same number in order to leave the house. Think like go on a date or something. Okay, so what we're going to do is we are going to start breaking up 8. Okay, meaning we're going to start dividing 8 to find pairs of numbers that can leave. Dividing to find pairs, okay, because they have to be a pair, a group of 2, to leave the radical, okay? So let's go ahead and divide 8. So everybody just draw this little factor tree. That means we're going to divide it up. Okay, so I know that 8 is an even number, so I can go ahead and divide it by 2. Okay, so 8 divided by 2, that's going to give me 4. Okay, so now we're just looking at 2 and 4. Do we have 2 of the same number that they can leave the radical yet? Nope, we just have a 2 and a 4. Okay, so let's break down. If we were to break down 2, that would only be 2 and 1. Okay, so we're just going to leave 2. Okay, but what about 4? How can we divide 4? We can also divide it by 2. That would give me 2 and 2. Okay, so now we're looking at these 3 2's. Okay, so do you see a pair, 2 of the same numbers that can leave the radical? Yes. Okay, so and it doesn't matter which pair of 2's you choose. You can choose these 2's or you can choose those 2's. I'm just going to choose these 2's. Okay, so these guys can leave the radical. Okay, one pair becomes 1 2 that could leave the radical. Okay, one pair. Okay, so it just became one, think like one couple was able to leave the house. Okay, but who was left inside the house, or what was left inside the house? Okay, the only thing we have left was that 2 right there. Okay, so 8 is not a perfect square root. We're not going to get a nice pretty number when we think what is the square root of 8. Okay, but how to simplify it, it becomes 2, one couple of 2's got to pair up and leave the radical, but 1 2 had to stay inside. Okay. Awesome, you guys. Let me zoom that out so we have that. Okay, so let's look at 18. Okay, so we're still looking for 2 of the same numbers that can leave the radical. Okay, so let's start dividing 18 up. So I know 18 is an even number again, so let's divide it by 2. Okay, so 18 divided by 2 is going to give me 9. Okay, so 18's got split up into 2 and 9. So I don't have 2 of the same number yet. 2 is just going to go to 2 and 1, so that doesn't really help us. But let's break up 9. How can we break up 9 or divide 9? Ooh, we know that 9 is a perfect square, right? Divided by 3 will give us 3. So 3 times 3 will give us 9. Okay, so now we have that 18 and 9 disappeared. We have a 2 and 2 3's. So what number can pair up to leave the radical or to leave the house? What couple can pair up to go on a date and leave the radical? These 3's can. Okay, so the 3's get to pair up. They create one couple, so 1 3. And then what number has to stay inside the radical? 2. Okay, remember 18 and 9 both got broken up, so it's almost like they're not there anymore. So we're only dealing with the 2 and the 3's. Okay, so the 2 was the only one that's left, so 2 has to stay in the radical. And there's our simplified answer. So when somebody asks you, what is the square root of 18? You can say 3 root 2. It's not a perfect square because 18 is nowhere on our list, right? It goes from 16 to 25. Okay, so the best we can simplify it is 3 root 2. Okay, but what about 64? Remember, 64 is a number that was on our perfect square list. Okay, so here's what happens when it's a perfect square. We can say, okay, well, I know the 2 numbers that can pair up and leave my radical, because 64 can be 8 times 8, right? 8 times 8 gives us 64, so if we divide 64, 8 times 8, oh, perfect. I see that it can automatically pair up to leave the radical. So they created one couple that could leave, but nothing had to stay inside. So our square root of 64, it's almost like we're going backwards. The square root of 64 is 8. That was the number that multiplies by itself to get 64. Okay, so our answer number 5, the square root of 64 is 8. Okay, let's look at number 6. Okay, we didn't star 6, so we know that 27 is not a perfect square. Okay, so that means we're going to have to divide it. Okay, so how can we divide 27? It's not an even number. Okay, so what can we divide it by? I know we can divide it by 3. Okay, so what is 27 divided by 3? It's going to give us 9. Okay, do we see a pair of numbers that can leave yet? Nope. 3 can only be broken down to 3 and 1, so that doesn't help us. So let's break down 9 again. Okay, how can we divide 9? Hint, look at this one right up here. Okay, we can divide 9 with 3 times 3. Okay, so we have 3 3's in there, but we only need 2 to create a couple. Okay, so we can see that 2 of my 3's can pair up. They can create a couple that can leave the radical. Okay, but then who has to stay inside? That one lonely 3. Okay, so one couple got to leave. 1 3 had to stay inside. And that is our simplified answer. Okay, let's look at number 7. Ooh, it's starred because we know that 16 is on our list. Okay, so what two numbers multiply to give us 16? Or in other words, what is the square root of 16? Okay, that's going to give us, we can break up 16, 4 times 4. Oh, perfect. There's our couple of numbers that can leave. Nobody had to stay inside the radical. So our square root, the square root of 16 is 4. Okay. Number 8. So 12 is not a perfect square. Okay, but we can go ahead and divide it. Okay, and here's the great thing. It doesn't matter how you guys divide it. You're still going to get to the same answer. So you can say, all right, well, 12 is an even number, so I'm going to just divide it by 2. Okay, 12 divided by 2 gives me 6. Okay, I don't see a pair of numbers yet, so I'm going to divide 6 up. 2, because it's even, okay, 6 divided by 2 is going to give me 3. Okay, so I have a 2, and a 3. What number gets to pair up and leave the radical? Okay, it's going to be the 2's this time. Those guys get to pair up. They create one couple that could leave the radical. And what number had to stay inside? Remember, the 12 and the 6 got broken up. So what number had to stay inside? The 3. So 2 square root 3. Great job, you guys. Okay, let's look at number 9. Square root of 45. So we know that 45 was nowhere on our list. Okay, it's close, right? We have 49, but we don't have 45. Okay, so we got to break it up. So how are we going to divide 45? Okay, it's not even, so we can't divide it by 2, but I do see that its last digit is 5, so we can divide it by 5. Okay, so what is 45 divided by 5? It's going to give me 9. Okay, I don't see a pair of numbers yet. 5 times 9, or 5 we can only break down to 5 and 1, excuse me. Okay, but 9 we can break up. Remember, we've broken it up a couple times. Okay, so we see that we can divide 9 into 3 and 3 again. Okay, so we broke up 45 and 9. What number can pair up and leave the radical? We see that the 3's, they can create one couple that can leave the radical. Okay, and what number had to stay inside? The 5. Okay, so the square root of 45 is 3 root 5. Okay, let's look at number 10. So this one we starred because we saw that 36 was on our list of perfect squares, right? So what is the square root of 36? Or in other words, what is the number that multiplies by itself to get 36? Okay, that's going to give us, we can break that down easy peasy in one step. We know that 6 times 6 gives us 36. Oh, beautiful. There is our pair of numbers that can leave. Nobody had to stay inside. So the square root of 36 is 6. Okay, those are your notes, you guys. There's an assignment that goes with it. Yeah, you guys are awesome.